Okay, so solving an example, use alpha at the 0.05 level to test P1 equals P2. Well, we can just start off with H0 and H1. We know we've got our P1 and P2 populations. We know H0 can only be equals. And going back, we're testing the claim that P1 equals P2. So actually, H0 is our claim. And so for H1, the alternate hypothesis, we need to use not equals. Looking at the formula for the test statistic, the first thing we need is P hat. And you'll notice that in either population, the student or the faculty, we're not given P hat. So let's go ahead and find P hat 1, where we'll take our x1 divided by n1. Notice that's not the order they came in the formula. I need to do 30 divided by 150. If you have 150 students, you can have 30 of them agree with something. You cannot have 150 of 30 students agree. So we have 20% or 0.2. For our second population, which in this case is faculty, I forgot to mention we don't need Q hat 1. So for P hat 2, 20 divided by 50 is 0.4. So notice 40%, 20%, the middle's 30%, but we have much more people, 3 times as much in the first population. So I'm not expecting P bar to be 30. I'm expecting it to be closer to 20 than it is to 30. P bar is to take your first population and kind of put it above and below each other in the first spot. Your second population goes into the second portion of the P bar formula. And 50 over 200 is 0.25. Yeah, closer to 20 than 30. Or just meaning it's not going to be 30, it's below 30. Okay, so we also are going to need Q bar, which is the complement of P bar. So 1 minus P bar, or 1 minus 0.25 is 0.75. Now we have everything we need to find the test statistic. Z equals, well, we start with P hat 1, which we found to be 0.2, minus P hat 2, which we found to be 0.4, and then we subtract P1 minus P2, but remember that's always going to be 0, divided by the square root of, and the formula says P bar 1 P bar times Q bar, so 0.25 times 0.75, and this goes over N1, and remember N1 is 150, plus, and again, it's P bar times Q bar, all over N2, which was 50. Working this out on the calculator, negative 2.82842, answering 2 places after the decimal gives me negative 2.83. Now for the critical value. Alpha equals 0.05 is given. I know I'm using the Z table because my test statistic starts off Z equals, and we've also decided that we have a two-tailed test. So two-tailed test on the Z table means I'll need to cut alpha in half to get 0.025. I will look inside the Z table, and we're going to find negative 1.96. That number is actually in the table. But don't forget, we'll have to answer plus or minus 1.96 because of the two-tailed test. Now we need to decide if we reject H0 or fail to reject H0. So I've got my bell-shaped curve centered over 0, my negative 1.6 and positive 1.6 critical values, and my negative 2.83 test statistic, which on a number line would be to the left of negative 1.96. If you can't see from here whether you reject or fail to reject, then you go find your critical values and shade to the closest edge. And since the test statistic fell into a shaded region, the critical region, then we reject H0. So having a claim of H1 and rejecting H0, your final conclusion should begin, there is sufficient evidence to warrant rejection of the claim that, and as you reread the question, you just have the claim that P1 equals P2. So that's all there is to write.